Hey guys, we are in section 4.2. We're looking at operations with matrices, and this is algebra 2. Our vocabulary is not too long today. We have scalar and scalar multiplication. So basically, when you have a matrix, let's say you've got a matrix A, B, C, D. You can multiply that matrix by a number on the outside, let's say 3, and this number on the outside is referred to as a scalar, okay? And so it means exactly what you think it means, and I'm about to do scalar multiplication. That's not what I meant to do. Let's undo that. It means exactly what you probably think, which is to multiply each term. And we'll see scalar multiplication happening here. Multiply each term or each element of your matrix by your scalar. And so we would have therefore 3a, 3b, 3c, and 3d. And so that's our vocabulary. Let's go ahead and apply. Another quick bit of information that we should keep in mind also is that when you have matrices, you can add them and you can subtract them. And these key concept boxes emphasize or show us how to do that. First of all, there's something to be said to when you add matrices or subtract matrices, you need to be having matrices that are the same exact size. All right. So notice that this is a 3 by 3. This is a 3 by 3, and that's the example that they use. And you'll see why in a minute. To add matrices, you need to take each element in each place, add them up, and put them in the same place in the next matrix, or the sum matrix, or the answer matrices. So a plus j gives me this first term would be aj, right? So what we're observing is that the location is going to come together as you need to, I don't know how to say it. You need to bring the elements in the same location together to be added together, and then their sum will be put in the same location in the sum matrix. That was a whole lot. But I think the picture probably is a better explanation of what I'm trying to say, right? So you see that I'd add D and in this matrix M, and then therefore the answer matrix will have DM in that particular place. All right. And similarly, subtraction will happen in exactly the same way, where you would subtract the two elements and put the answer in the same space as where the two elements were subtracted. Another concept that I want to talk about, or at least this kind of comes at the end of the chapter, but I at least want to talk about it a bit, is some of the ideas from addition and subtraction in general will be applied to our matrix operation. So you can see here the commutative property of addition is in place. If you have a matrix A and a matrix B, such that you add A plus B, it's going to be the same as if you added B plus A. The result will be the same. Similarly, associative property is in effect if you've got three matrices, A, B, and C. If you choose to add matrix A and B first, then add C, you're going to get the same result as if you added matrix B and C first, then added A. The next thing we want to do is look at the distributive property. And in a way, you saw in our little example of what scalar multiplication was, it felt like the distributive property. So we see here that if I have a scalar and I am going to multiply that scalar times the sum of two matrices, it would be the same as if I multiplied that scalar by one matrix and then added that to the next matrix multiplied by that same scalar. I feel like I'm super tongue-tied. I think looking at these diagrams and looking at this information in this way is probably more sensible. If I'm not being clear, please let me know and I will happily talk to you about it. So here's what we got. We're going to add A plus B, and here's A and B, and I think you guys know exactly what's going to happen. It's kind of fun. I think I like to tell students how easy matrix addition and subtraction is. It's so easy, it's almost child's play, right? So we're going to add 4 plus a negative 3 and we'll get 1. We'll add 2 plus 5 and get 7 here. Negative 6 and 7 will give us 1, and 3 and negative 9 will give us negative 6. So here is the sum. Here's the matrix A plus B. That's what we just showed us here. And that's all we got to do. Over here, we're going to look at this guy. Here's A and here's B, and we are going to add these guys together. But wait, look at that. The situation is such that the two matrices have different sizes. Their dimensions are not exactly the same, so addition is not possible. Just for the sake of it, let's go ahead and remind ourselves what the dimensions of this matrix is. Remember, it's row by column. So we've got 2 rows and 3 columns. So this is a 2 by 3 matrix, where this one is a 2 row by 2 row matrix, and so we can't deal with that. Let's look at another example, subtraction in the house. And so subtraction works a lot like we had last time with our addition. I'm going to take each element and observe their location. I can't subtract these because their dimensions are the same. I've got 2 2 by 2s, but 9 minus 3 is going to give me 6, so I'm going to have that first element there, and then 2 minus 6 gives me a -4. -4 minus 8 gives me a -12, and 7 minus a -2 gives me a +9. And so here's my resultant A minus B matrix. Here in example 3, we're going to use a matrices to model real-world data. So, animals. The table below shows the number of endangered and threatened species in the United States and in the world. How many endangered and threatened species are there on the world list? Let's read this again. How many more, I think I didn't say that. How many more endangered and threatened species are there on the world list than on the United States list? And so we're going to use matrices to answer that question. So let's create 2 matrices, one with the United States and one with the world. All right, since the question said how many more endangered and threatened species are there in the world than in the United States, I chose to put my list of world endangered, I should put a little E here, and threatened animals first as opposed to second, so the subtraction makes sense. And so basically I've copied it. MB RAF stands for our mammals, birds, reptiles, amphibians, and fish. And we're going to subtract them and put the values here, and then we can find the difference, or how many of these species are endangered that are outside of the United States. And there we go. I just cut and pasted the actual answer in from the textbook because I thought that subtraction would take a long time. Please don't do that in your homework assignment, though. Don't just cut and paste answers from there. Okay, but I think you guys get the idea about how to do the subtraction. All right, so let's look at scalar multiplication. They asked us to calculate what is 3a, a being this matrix, and we saw a quick example of that earlier. I think you guys know we're just going to multiply each term by 3, and so we get 6, 24, -9, 15, -27, and 3 times 2 is 6 again. And so that's what our resultant matrix is. Sometimes we can combine operations on matrices or on a matrix. And so what you see is that we're going to take A and B as they are. We're going to multiply A by 5 and subtract 2B from it. And so we could do it all in one fell swoop if you felt like really confident about the way you're doing math. And sometimes, I'm not going to lie, sometimes I'm like, I am not going to write this 92 times. Are you guys mad at me right now because I'm being mathematically lazy? Notice I put a 5 and a 2 there, and I'm going to do the subtraction. You can do it your way and tell me if we get the same thing, right? So I'm going to do it right now anyway. All right, so I know that I can subtract the resultant matrices because they have the same size. And so basically I'm going to say 5 times 7, and then I'm going to subtract 9 times 2. So 5 times 7 is 35. 9 times 2 is 18. 35 minus 18 is going to give me 17. And I'm going to do it again. 5 times 3, that's 15. 2 times 6, that's 12. 15 minus 12 will give me 3. Again, 5 times -4, -20. 2 times 3 is going to give me a 6. -20 minus 6 is going to give me a -26. And then 5 times -1 is -5. 2 times 10 gives me 20. -5 minus 20 is -25. I think that's the right answer. And I feel pretty good about myself. If you wanted to, you certainly could have written out the 2 separate matrices like this and then did your subtraction. But I mean, if your brain can do it without having to write it out, that doesn't bother me. Truth be told, though, if you're like taking a test or have to put information down, it's better to just put it down. So if you have a mistake, I can give you partial credit. But if you're doing your exercise and you're trying to work through it, knock it out. I'm babbling and saying all this because we have come to the end of our lesson. So this is what we've covered so far. We're going to get into some more interesting operations and uses of matrices. Right now, they seem a little bit boring. They'll get a little bit more interesting in the next few sections. So let me know if you have any questions or concerns. And if not, I look forward to talking to you soon with another lesson. Take care.